Okay, so today is 9/7/16. And this is advanced topics. And we will be reviewing, we're looking at quadratics some more. And other types of equations.
Let's go.
Let's do a little red A here. Okay. Someone have questions? Yes. No. No, you can go get it as soon as the hall pass is available, wherever it may be. So as soon as someone gets back with the hall pass. But you should make sure that you bring your stuff to class.
No, it's I left them on the like I was using it and forgot to pick it up. So what you need to make sure.
Make sure that you're more responsible and you make sure, okay, do I have everything I have going into advanced topics?
Yeah.
Okay, I understand, that's a part of it. Okay, so we're looking at quadratics and other types of equations. So this is going to be looking at some section 1.5 and 1.6. So we'll write that off here. Section 1.5 and section 1.6. So let's review some things that we know about quadratics. So if we have, and this seemed to be a point that I want to make very clear because it will definitely be on a quiz or a test. If you're giving something graphically, understanding it. We have this one. What do we know? Oh, that's not good. Let's go back to here. Let's go with blue is good. Sir, we do have plenty of paper here and in the back if you want to start taking notes. Don't wait to redo it later. I encourage it.
Just so you might not need to know that.
So this is a review of something that we touched on, I think, last week or so. What can we say? What can we say about if you're given graphically these quadratics? Right, these are all quadratics that fit the form, function the form ax squared plus bx plus c, where a is not 0. What can we say about each of these different examples here? What can we say about the first one? What's some descriptions we can write about this? Well, we all agree that they're quadratic. So it's the quadratic. If you say they're positive, what do you mean by that? They're positive. What's positive? Can you be more specific?
Yeah.
Can anyone help out? You're on the right track.
Like, is the positive squared?
Yeah, I think you basically are saying that you're so the a coefficient, the coefficient of the x squared is positive?
Yeah.
Yes, so good. So it's quadratic, and this guy has a positive a. Okay? Everyone knows what a that's referring to when we have the form ax squared plus bx plus c. Alright, so let's write that up here. Let's go with a little purple. Ax squared plus bx plus c. If this were written as a function, say f of x, this is the general form here, right? Right, and a cannot be 0, otherwise it would not be. So let's go with this. If A were 0, what would we have? A linear equation, correct. Whoever said that, very good. You would have a linear equation, correct? So, positive A for this guy. Okay, what else can we say about this guy? Thank you. It's got 2 complex roots, or you can say 2 imaginary roots. 2 complex roots. And why is that? Correct. It does not touch the x-axis. So its roots are going to be complex or imaginary because you can't see it on this plane. Because remember, this plane, this panel, represents all the possible points that make up this plane are all going to have real coordinates. So we have a different plane that sticks out like this. So if I could pull this off of the screen, you would see the other dimension that exists where this would have to be on a separate plane for this to have roots. Okay? So it doesn't touch the x-axis, so it has 2 complex roots. Quadratic, positive A. A is positive, yeah, okay. How would we describe this? Do you guys know what word that was? Very good. Good word to know, mathematical word. Okay, good. It's a quadratic, so it's definitely a shape of a parabola. Good. Think of, the way I always remember it is the word cave. I think of a cave. If I look into a cave, like this, or if I'm inside the cave, I can see it like this. But the cave comes to mind when I see these shapes because the word I'm looking for is concavity. Concavity. So is this concave up the whole way? Or concave down? Easy to remember, the word up starts with a U. So all 3 of these are concave up. So it's concave up, so positive A, therefore it is concave up. If the A were negative, it would be concave down. Okay, so this descriptor seems to fit for this one. It also seems to, what about the, in terms of the A coefficient for this and this guy?
Still fine.
Are they still both positive for each of these?
Mm-hmm.
Yes, because they are both concave up. So these descriptors here, if I can just select these 2, looks like it's not going to let me do that. So what I'll do is I will copy, and then I will end up pasting. Let's put it here, but I'm going to erase where it says this thing about 2 complex. This may not be true. Okay, so if we continue on with this is also a quadratic, positive A, concave up. What about its roots? Yes, it does have 1 real root. And why does it have 1 real root? It just touches it? Yeah, it just touches it. So this has 1 real root. So I'm going to write 1. And for real, I'm just going to use that fancy looking R. We just all know that just means real. 1 real root. Okay? And then finally, this last guy here, let's see if I can bring him up a little bit. Now when I paste it, it's not giving me the option to drag it, so that's kind of random. If I go over here and I do this, and then paste. It doesn't look like any of those. Alright, here we go. Alright, that's kind of pointless. So we'll have to write it out here. So this guy is also quadratic. therefore the shape is a parabola. And its A is also positive. Guys, please, no talking if you have a question. You know, is also concave up. And what about its roots? It has two real roots. We all see that it has one real root here and another real root right here. Right? So it has two real roots. Okay? One real root here, and to be more specific, we would say that this has a multiplicity of two. Multiplicity of two. So if it just touches, it's going to have a multiplicity scenario there. And because it is a quadratic, meaning the polynomial of degree 2, the most number of roots you can have is 2. That's it. You cannot have more than 2 for these. This one only has one real, but it repeats when it's in factored form. I think we saw a problem one time at the end of the period. We were getting towards the end, and we saw, bless you, we saw where in factored form it was something like, for example, 3x minus 6 times 3x minus 6 equals 0. And I said, look at this. We have two factors that look identical in linear factored form. That's the multiplicity scenario because they're the exact same. So these are the three possibilities we have. Any questions about these? So the homework that you have assigned, looking at solving more quadratic type problems, up through, on the last one is 172. They have a mid-chapter checkpoint, and now let's go into some other types of equations. This is going on page 158. So we should start looking at problems that we should be comfortable with. Page 158. Let's undo this. Let's pump it up a little bit. It says, example 1, 3x to the 4th is equal to 27x squared. Would anyone like to come up here and attempt to solve this, meaning find x?
Oh.
Oh, no? I know a lot of you are coming from different backgrounds from your last course. Raise your hand if you've done a problem like this. Yeah? Okay, so here we go. Well, you have some ideas back there? Okay. Okay, so we're looking at this. Let's see if we can go with what we've been comfortable with so far. Now let's go with some we'll go with some factoring, but before we do that, what have we had the pattern of doing here typically? Once we reach quadratics, what's the first thing we start going towards before we try to solve? Regardless of whether we solve it by quadratic formula or by factoring, what's the first thing we typically do? Yes?
Get all the x's on one side.
Mm-hmm.
And
Yeah.
then make sure it's just numbers on the other side.
Okay, that would be true if we were solving something that is linear. That would be true. But for quadratics, what do we do? Yes. We said equal to 0, so you're on the right path. Let's go ahead and let's get everything over on one side so that the right-hand side or left-hand side, whichever side, one of the sides is 0. So looking at this, we would say let's go ahead and subtract 27x squared from both sides. Okay, so we do this. I see some of you are not taking notes. I'm a little concerned.
I'm visual learning, so I don't.
That's fine. Writing it down though will probably help with most of your old memory. I know you guys are comfortable with where you stand and how you learn things at this point, being juniors and seniors. But definitely consider the fact that writing it down, why not do it during class since you're here, definitely help you with your memorization and solving these. Okay, so now we're here. So I heard, let's say, factoring. What is the greatest common factor out of these two terms here? 3x squared? Yes? So 3x squared. And what would we have remaining if we factor out 3x squared? X squared minus 9. Christian, do you know what we do next? No? You do? No? Okay. Does anyone know what we might do next?
I did all the simplified ones.
Anyone recognize anything? Did you say this is math? Oh, is that what you recognize? Yeah, that's good. I like true statements. Good. Yes. Ah, good job. That's the difference of two squares. Correct. Yes. Good. It's the difference of two squares.
I don't remember what that is.
So let's go back over that. So let's go to here, go back to blue. So this is, we're talking about this x squared minus 9, this is a difference of squares, yes.
Yes.
What does the word difference mean? Subtraction, yes, yes. So in squares, yes, this is a square, right? This is a square. Even if you had perfect squares, even if they weren't perfect squares, we can still apply it, by the way. But they're perfect squares, so let's go ahead and definitely do this. So let's do this. So we still have 3x squared.
Why are you doing it so difficult?
Hold on, I will answer that question in just 1 second. So we have 3x squared, and then we have, what would this become? X minus 3
Equals 0.
Was that everything?
No. Oh, another one. I
Right?
another.
Yes.
Sorry.
And it says x equals positive.
So, okay. Next step, so let's go up to here, let's continue our work. Now, what do we notice about factoring? It's something that's a recurring theme here as to why, I think I mentioned it, why is factoring important, yes? Something cancels out.
The x, this is why you doing it.
I
asked anyone want to come here and show it, do it, please.
Can you erase that step?
I appreciate the collaboration.
Can you erase the third we did, the last one?
Why don't we do this? Why don't I finish this, and then you show me or show us how you would do it?
I'm not going to.
Please?
Do that.
I want you to say please.
She's right.
There you go. That wasn't too hard. Okay. So let me finish this. So why do we factor? Why is factoring important? What do we notice about this line, this part of this left-hand side versus this guy here? What is the difference?
What are you doing? You're trying to get it equal to 0, so you're across. They're going
This guy's equal to 0.
the 3x squared. You want that equal to 0.
Okay, so you're going the next part. But I want to understand why is factoring important. What does it allow us to do? What does factoring allow us to do?
Take out restrictions.
Factoring is important because what it does, factoring, what it does is it can change something that's simply a sum or difference and make it into a product. Notice now we have a product. We have this times this, as opposed to up here we just had some term minus some term. But now we have a product. And because it's equal to 0, why we do this is because now 3x squared, like you're saying, could be 0. It could be 0. These don't have to be 0 for this to be a true statement. Only one of them does. So now we can say, well, 3x squared could be 0. We could also say that x minus 3 could be 0, or x plus 3 could be 0. They don't have to be all 0 at the same time. Do you guys agree? Because anything times 0 is 0. Okay, so these do not have to be all 0 at the same time. So let's go ahead and solve this guy. 3x squared equals 0. So I have x squared equals 0, and I get that dividing both sides by 3. So x squared equals 0, okay?
And then you want to get the x squared, so you will put your square root.
Take the square root of it, yeah. So if it's squared, we'll take the square root of it. So
x equals
if I square root, yeah, so x equals, good. So if I square root both sides, I would have x equals plus or minus the square root of 0.
And x equals 0.
So this x equals 0, right? This particular value, the plus or minus, is not essential here.
Yeah.
Right? Because plus or minus 0. 0 is a neutral number, right? It's even, but it's a neutral number. Okay? So I'm going to box this because I want my teacher to clearly see my answer. Okay? Let's try to keep that in mind. So then now here, what do we have?
Please tell me.
Well, you did it.
Can you tell him what? Can you tell him what? He is doing it. He's doing good.
You did it that way. The way I did it, I just...
Hold on, let's finish this. Let's finish this. And then we'll talk about what you want to do. Okay, so build these equal to 0. Right? If I add 3 to both sides, right? So x equals 3, okay. Okay.
And then x equals negative 3.
And then x equals negative 3, because to do that, I want subtracting 3 from both sides.
Yeah.
So x equals negative 3.
Yeah.
Okay, and I'm going to use a nice different color here, because I can, to box my...
Positive and negative 3. But you did it that way, I just did it straight from x squared, subtracting 9, 0.
Okay, so let me touch on some things here. And I'm going to do a certain way that a lot of students probably want to do, and it may not give us all the possible solutions, and you'll see why. So this is the correct way to do it. I want you guys to understand this now. This is the most proper way to answer this, to solve this problem. Okay? For those of you that are taking notes, and those of you that are paying attention, and this is correct. Okay? Now, let's go back to the whole multiplicity thing. Okay? Because for those of you that hate graphing, I hate using the word hate, or maybe don't feel comfortable with graphing, or not sure of how this relates to a graph, understand this. In factored form, 3x squared. When we solve for that part individually, we did it as set equal to 0. What did we notice? Plus or minus 0. So, what do you think? At 0, when x is 0, will the graph touch it, or intersect, or not touch it or intersect at all at 0? It will touch it. It will touch it because we have this situation where it is squared. It has the multiplicity of 2. Exactly. That's this exact scenario. If I graph this graph will just touch the x-axis at 0. Okay? Now these have a power of 1. They're of 1 degree, these individual factors. So will they touch, intersect, meaning pass through, or not touch or intersect at 3 and negative 3? They will pass through, because in factored form, they're of degree 1. You guys okay?
Yeah.
Yeah. Okay. All right, so this is the way that you could approach this. Now, let's show you a way that, now you have an idea. What's your idea, sir? You said you would solve this differently. I said I'm doing this the hard way.
All right.
Let's start from the beginning.
Yeah.
So let's take, let's just do this. It doesn't want to do that. So let's go, if I have, it's 3x to the 4th, it's 3x to the fourth equals, was it 27x squared? Okay, what do you think you want to do first?
Well, first I would subtract 27x squared to get the whole and the same side.
Okay, then what would you do next?
And I just go, I would take that square, I would take 3x squared, I would 3x over 4. I take 3x squared out of that and I do 3x squared and parentheses x squared subtract down to 0.
Okay, so that's what we had. Okay. So you're so far. Okay.
And then instead of doing what you did on that, I would just do 3x squared equals 0. Yeah, we did that. And I just do x squared subtract 9 equals 0.
Okay. So, yeah, pretty much the exact same thing that I did. The only difference is that you wrote this equal to 0, which eventually you would have to factor it anyway. Or what, add 9 to both sides and just be careful. Okay, no? Well, you have to come up with these two guys. Yeah. So that sounds similar. It doesn't sound that much different. So what I thought maybe you were going to say is this. Well, let's just go ahead and divide out from each of these. Let's divide out 3x squared because they both have that in common. It'll make the equation more simple. So you go ahead and you do this, and you have x squared equals 9. So x is equal to plus or minus 3.
Okay, so that's what I do. Woo! All right.
Okay. Right. So this is the way you don't want to do it because what happened when we divided both sides by and contained a variable component when we divided out x squared on each side? What happened?
We didn't get 0.
Yeah, we did not get 0 as one of our, which is absolutely one of our solutions. So this is a common mistake that you want to avoid making. So we're going to put a big red X through this. This is not what you want to do because you may not get all of the solutions. Okay. So back to the main point that I've made in the past that factoring is your friend. It'll present you with all the solutions. Any questions before I move on to another problem? Okay, no questions? Next problem, we're going to look at what looks like, so the last one was we call this a quartic because it's of degree 4, but you can just say degree 4 polynomial equation. Here we're going to look at example 2 on page 159. And it says we have x cubed plus x squared equals 4x plus 4. Okay, so any ideas on what you might do first? And I'll give you a hint, it's a similar process to what we've been doing. Yeah. Set everything equal to 0, yeah. So, and it doesn't matter which side. So, because this guy's a positive, it's a positive coefficient, I'm going to get rid of these two guys. So, I'm going to subtract 4x, and I'm going to subtract 4 from each side. Okay. You getting it? You're just watching? Yeah. Okay. All right, so then here we have, let's say, x cubed plus x squared minus 4x minus 4 equals 0. Can we simplify this before moving on, which is something we always want to do if we can simplify? Or is this fully simplified?
You can factor it right through.
No, I'm not yet. I'm asking about simplifying. But you're already on the right. Okay, so why can we not simplify this? There are no like terms. Okay, no alike terms. You have a cubic, a square, x term, and a constant, so there's nothing alike. So now, some of you may be looking at the book, you may know, okay, factor by grouping. Because you may try to attempt to factor this, and then you have this guy hanging off here by addition, and you wouldn't have all product. So the other method that you guys may have already worked on in the past, and this may be a review for you, is factor by grouping. Now, how would you want to group these? That's the question. Well, I typically look at this guy, and if I'm going to group him with something, I want to group my constant term, which is the most simple. I want to group him with something that something could be factored out. So notice it would make no sense to maybe group this guy with the x cubed, right? I probably wouldn't do that first. So let's go ahead and change everything to addition to be safe. Let's go plus negative plus negative. Why do I do that? Good question. Okay, so the reason that I do that, good question. The reason that I do that is because it lets you avoid making the simple mistake of thinking that you cannot associate that negative with this 4x. Because a lot of students will do is go this, okay, parentheses, parentheses. And they'll end up making a statement that is not true because they're implying that you're now minusing this whole thing, but then you just changed the equation. So if you make it all addition, you are allowed, there's called the associative property of addition, but there is no associative property of subtraction. The associative property of addition says I can just go like this. I can group these two, and I can group these two, and it's the exact same equation. It doesn't affect anything. So I do it to be safe, to avoid making a simple mistake. So let's realize that all subtraction can be written as addition, and all division can be written as multiplication. Some good rules here. So now let's focus on. So all I'm saying is let's focus on factoring just these two by themselves, and then these two by themselves. So if we factor these two, x squared would be what, the greatest common factor, okay? Leaving me, very good, x plus 1. And over here,
4 or negative 4 or whatever.
4 or negative 4. Okay, so let's take out negative 4, and we're left with, okay, so we actually, this worked out convenient for us because what do we now notice here? We notice that this guy, and now you can think of it like this. You think of it like this. If you want to associate, okay, this is it's one thing and this is another thing. Each of these has what in common? X plus 1. They have, what's in parentheses, they have that in common. No matter how complicated that looks, the simple fundamental rule here is they have it in common, so we're going to factor that out of each of those. So here, they each have x. So I'm going to factor that out of each of those. So now I'm left with, if I factor this out of this, I'm left with what? X squared for this guy, and over here, I'm left with, which I don't care whether you guys write x squared minus 4, x squared plus negative 4, same thing. Difference of two squares, good. You have to recognize that, good. So back up, so up to here. So x plus 1. Now what will this factor out to? Because the difference of squares.
I don't know, x plus negative. X plus, yeah, or, oh yeah.
Okay. Now this now equation has been set equal to 0. It's been fully factored. What is the power of each of these factors? Like what's the degree of this guy? What's the degree of this factor x plus 1? What is the degree of it?
1.
1. Raise your hand if you don't understand what I mean by that when I say what's the degree. Okay, the degree is the highest powered term. The highest powered term is an x to the first power. We don't have to write it once. Understood to be x to the first power. And the degree of this? And the degree of this? Okay. So, at x equals -1, is our graph going to touch or pass through at x equals -1? Why? Good. Because the degree is odd. That's the reason. So whether it's first degree or if it were third degree or fifth degree or seventh degree, it'll pass through. If it is even, like we had when we had the x squared, that's when it just touches. That's the relationship. So when it's an even, when the factored form is an even degree, it touches. If it's an odd degree, it passes through graphically. So we have x, all the solutions are x equals -2, -1, and 2. I'm just listing them least to greatest. You don't have to do that. 1, 2, I'm saying there's 3 unique solutions. Is that possible when we have a cubic equation? Is it possible to have 3 unique solutions? Can we have 4 solutions for this?
Yes.
No, we cannot. Because the highest degree is 3. That's the relationship. You cannot have more roots than the degree of the polynomial equation.
So what if our answer was positive negative?
Yeah, that's fine. That's fine. You guys can write it one more way. X equals plus or minus 2, comma -1, or 3 different boxes. As long as it's clear, boxes are answers. Yeah. All right, very good.